cat interviews at Uber, Confluent, Indeed, and many more companies. I've seen it all. After countless hours on the other side of the table, I know exactly what top companies are looking for, especially in LLD. In this course, I'll share the insider blueprints, what to focus on, especially key design patterns, how much multithreading, very important, counter question, traps, and how to tackle them confidently. This course is structured, practical, and tailored on what companies are looking for right now. Let's get you interview ready right now.
Now, after spending 1.5 hours in one of the biggest problems which we did for LLD, let's move on to another one, design cache. Now, a small prerequisite before we go on to this problem is that you should have watched, again, like we can simply come onto the home page and click cache or write cache. Then this is one article. Again, you can simply watch this one video of cache. This one video is the core, but this is not exactly what we're going to see in this video. This is much more than just a simple LRU cache. So again, prerequisite, watching this video, and then we can start off. Now, one more prerequisite, please watch these videos in a sequence, which means that please watch the normal LLD videos. Then this also please watch in sequence, because everything cannot go in one video, and that's the reason I have primarily mentioned many things in many videos, and have also pointed out, because see, this was very in-depth about repository patterns, service patterns, so on and so forth. It was completely focusing on the actual design patterns. Again, this focused on multi-threading as well, but a basic one. This will focus on multi-threading along with cache logic, which is a DSL concept, along with generics, which obviously you should have read while you were covering your OOPS. So all that, again, I could have covered here also, multiple stuff. But again, the catch is that slice that stuff in different videos, so that not one video becomes 5 hours long. Coming on back, let's start off with a cache system. Now, I assume that you guys would be knowing what a cache is, right? So basically what happens that whenever anyone, let's say any of your service, let's say obviously your client will call a service, and then again I will be replacing my service with a client as well, because I can just pick that hop that the client, let's say, is talking or asking some data, and that I have, as a facade, I will just hide it. But the logic is that whenever someone calls something or asks for something, that bro, I inserted a row, which means that for this key, this is the value, get me. So if cache would not have been there, I would have gone directly to DB and then would have gone it. Now we know that if there are multiple reads and writes onto the DB cannot handle that much high volume of read and writes. And that is the reason we have cache, right? Again, we have Redis, we have Cassandra, we have Redis, we have Memcache. With that, the speed is much faster. So what we keep is that we keep a cache at front. Now, if you want to do some writes, okay, do here. Do some reads, okay, do here, and so on and so forth. Now, there are multiple write policies with which you can actually, tweak the consistencies. So if you want highly consistent system, then you will choose a different write policy. If you want eventually consistent system, then you would use a different policy, and so on and so forth. Now, with all that said, did you realize the challenge here with your normal LRU problem? Your normal LRU problem, just imagine that I have a simple cache in which I would be just inserting a data, and then I will be getting a data. And the moment, again, I'm hoping that you guys have watched it and then you're watching this video. So the moment you insert more data, you realize that the cache size becomes full, and then you evict some entry, which is in the, which was obviously LRUs there, like least recently used. So whichever is recent right now, I will keep it. Whichever is not, I will remove it. And when my cache becomes full, because obviously cache is in memory, like obviously you are not storing anywhere and there's no persistent storage as such. So you're using your memory. So for that, you cannot infinitely increase it. You have to evict out after a certain capacity has reached. That was your entire cache logic, which you have covered in this video. But we realized that in an actual scenario, what will happen? This was the cache where we had this logic. But now what will happen is that because this is the cache, firstly, multiple people will should be able to read and write concurrently on it. That is the thing. That's the thing, right? Multiple people, like multi-threading and concurrency. Why? How it will come up? Obviously, multiple people have to try to access it. Now, whenever multiple people will write onto it, and then I have to read. So, like, there are multiple writes, multiple reads, multiple writes, multiple reads happening. For that, I know this is a cache, and again, there will be always a backing DB. Now, usually in these terms, you don't put up a DB because you don't want to complicate as such. But if there is some write happening, and as I was mentioning, that there are write policies which helps us to say, okay, if again, although if you are not aware of all that, no worries, I'll explain everything, but I'm just giving an idea how exactly the cache logic originates. So I will have different write policies which will help me, okay, if it's eventually consistent, if it's highly consistent, so on and so forth. So obviously highly consistent with what? Eventually consistent with what? Actual database. And that is the reason, actual database, and that is the reason we have to incorporate database as well. So this request, how it actually enters my cache and my database. Now, with all that said, again, if you want, you could have ignored this altogether as well. But if we are incorporating write policies, that how you write, ultimately it means that how you are interacting your cache and your DB. Because obviously any cache will be backed up by a DB. So I can say it as a backing DB. Now, with all that said, let's see that what flow we're going to cover in this video. So firstly, I'll tell you, a couple of things about cache more, although I've told a lot, but yeah, I'll tell a bit more. And then we'll go on to the actual into setting, in which we'll discuss what exactly points you can put up when you are covering cache. Although I highly recommend that it may be possible that your interviewer also might not be knowing that much. So it's fine to discuss the requirement first, and then whatever is mentioned, then go on to it. Maybe it is possible if it's a very, very basic LLD for a cache, then maybe all these write policies are not required. You can remove that. You can only keep the eviction policies. Again, I hope so that if you have watched LRU, eviction policies is what entry are you gonna evict. If it's least recently used, if it's least frequently used, and so on and so forth. Now, continuing ahead, then we'll discuss about a couple of design patterns which we can use. Primarily, this video will focus on not much design patterns, although we will use a couple of design patterns, but this is going to be focusing on generics, right? Multi-threading, and also your design principles. That keeping it a bit separate and following solid and stuff. Now, design patterns, we will be incorporating strategy again, although we can incorporate factory, observer, and so on and so forth, but we will not touch it because, again, as I have already mentioned, that for that we have already spent a lot of videos on it, right? So the task here is, obviously the main task is to cover multi-threading, but on top of it, just to give you a flavor of generics as well. Now, again, it can be a bit tricky for the first timers to understand about generics, so I'll highly recommend that if you don't understand it, you can replace that generics with the actual hard-coded let's say if it's a string, replace it with a string. It's completely fine if you don't understand much. But yeah, if you just watch this one's portion of generics and wildcard, you should be able to understand at least generics. And then yeah, if you try it, you will be able to write as well. Coming on back, then like in the flow, we'll discuss the entire code, which can be a bit complicated, although for the folks who want to get the code, you can just visit my GitHub, and in that you will find the corresponding code. This is the corresponding code structure. Again, I'll just give a highlight on all these things, but obviously it's much easier to go through it in actually OneNote fashion, because again, I'm telling because primarily in an interview setting, you have a page, right? You don't have a code editor like Code Signal where you can make folders, where you can actually make all that stuff. No, it doesn't happen like that. So this kind of structure is not possible. And again, you don't focus on RN, I will make a package and then I will just define my code. No, you will not do that. In a single piece of code, you're writing all your corresponding classes. So the catch is that you should be knowing that what classes to write, what attributes to write, and then what I can cover. So firstly, I can cover my core entities. Then I can cover my core services, and then let's say my main. That is how you actually write. So you should be just focusing on core entities, core services, and then your main. Right? No folder structure. No, I'll make no. I'll make one utilities package. No, 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 no. Impossible that you will go into it. Now, obviously, then we'll cover everything, and then we'll also cover the main code. Now, coming on, let's start off with the actual stuff, because this is going to be a bit long video, because I'm going to teach you a couple of new concepts which you might not be knowing about. Before that, obviously, the cache task is to store and retrieve data efficiently. The word here is efficiently and fast. Because I have limited resources, so when I say store or retrieve, I will do insertion, I'll do retrieval. But because it is limited resources, I have to do eviction. Based on some policies, obviously we mentioned that we have different eviction policies. We will be focusing on LRU in this case, like recently used, that whatever key is evicted is the key which was very last used. We also have other eviction policies, for example, LFU, least frequently used, although very rarely used because it is not that good. The mixture of LFU and LRU is one of the very good algorithms, which is kind of used also in industry. But again, LRU is one which everyone also knows, and also you can implement. It's a very common TSA question. Now, in a general setup, it looks like that you can have the key and the corresponding value, and you will for sure support put, get, remove, and so on and so forth. Now, again, I've already discussed about different eviction policies which you can have. On top of it, you will store the data, you will retrieve the data, and obviously at a capacity, you will evict some things. And you primarily want to handle concurrent access. We will see that what issues can come up with this concurrent access, but yes. Now, on top of it, because it's concurrent access, so we want things to be, thread safe, multi-threaded concurrent environment should actually work completely fine. And eviction should be automatic, which means now again, when I say automatic, it can be two things. I can run a background thread, which can simply keep on evicting, just so that my, task I can offload and it is not on runtime, so what happens in general scenario is that if you have some task, so one thing is that let's say if this is your cache, if this is full, then you can, whenever the person comes up and puts some entry, then obviously then you will evict it and then say, bro, I don't have space, and okay, you have to go away. Or there is another thing that you allow, because let's say if it's one entry, you allow it, and then as a background thread, the last entry will automatically be removed. So it will keep on checking if the size has increased by large, so it will simply remove it, so that both these processes can run parallelly. So again, the add-on benefit for a background thread is that your current write is not just doing a lot of tasks, it is doing uniform tasks for every write. And the worst part about background thread is that obviously it will take its own CPU, again come back, do a check, and so on and so forth. So these are benefits which you can tell always to anyone, that if you want to keep things automatic versus you want to do manually. You will see that in other problems as well, which you're going to cover in this LLD series, we will keep things automatic as well. Like we will run a scheduler thread, which will actually keep on scheduling, and like at an interval, we'll keep on doing things. Now, obviously, there will be cache hit, and I can just maintain that. That's optional. This is also optional, that I can expire my cache entries. Now come back to the main problem, that how will you start off? Start off, the person will simply ask you to design a cache system. Now, the moment you design a cache system, you know that you will be storing and retrieving key value pairs, right? Keeping it very simple, we will have a key and a value. Now, both of them will be generic, that you can put literally any key, you can literally put any value. People usually hard code them by string, obviously not required. Even if you make a class, no, I'll make a class and we'll say this is my key class. But then in the key class as well, people tend to hard code by saying string value. Obviously you have ultimately hard coded, right? So as to not hard code, I will keep my key as key and value as w. Whatever you want, you can bring up here. If you want, you can replace it with a class as well. It's completely fine. Now, the task is to manage limited memory. So obviously I will have a capacity. The moment the capacity breaches, I will have to have eviction policies. We already discussed that we have primarily LRU and LFU. We'll discuss only LRU and we will not go on to LFU. It's impossible to actually go on to all of them. Now, I should primarily support operations of getting and writing. That's one thing. Because I want to put key value pairs, and although not a very hard and fast tool, but yeah, here in this case we'll use generics. But again, as I mentioned, for the folks who are not comfortable with it, they can replace this with a hard coded value. So you can replace your string with a you can replace your key with a string and value also with a string. It's completely fine. It's completely fine because the core logic is how you handle multi-threading and not generics. So I always say there's priority to every question. Here the priority is first multi-threading, second is generics, and also again you can remove generics and say I just follow the corresponding design patterns and design principles. Now, obviously it should be thread safe because there will be multiple concurrent operations. Now comes the fun part. When we say concurrent operations, so first comes is that okay, concurrent operations on cache, on your cache. Now, obviously, when I say cache, my cache, when I say concurrent operations, if it's a write operation, then obviously I will have to put that data to a DB, which means a write policy will kick in. So I should be knowing about a write policy. There are three main write policies. We have write back, write around, and write through. The way, again, people always get confused in it, so I'm telling how you will remember it. That what is write around, what is write back, and what is write through. Write back says that bro, I will update the cache whenever the entry will come up to write something on the I want to write something in my system, so I will update the cache immediately, but I will write back to my DB later on in time. Whenever, again, I'll flush it, I'll do basically I'll not do instant write to my DB. No, I'll just keep it okay. Whenever you get time, bandwidth, resources, or however the business functionality is, I'll just write it back to the DB later on in future. So what happens with this is that now my cache is pretty fast because now cache, because see, for anyone looking from the looking from this end, he just do rote, like he just give a rote command, and then cache, because it has a very fast write, cache rote and then give back a acknowledgement, yes, it is done. So from this person, from this client's perspective, this write was pretty fast. So the write performance increases and it's pretty good, but the main loss is data loss. Why? Because what if the memory goes down? What if there's abrupt something happened, like some calamity happened and something happened and then this went down? What will happen is that all the writes which happened, which haven't written back to the DB, all are lost. So obviously it comes at a data risk loss. Now, technically, data risk loss, people can expect from a cache to have data risk loss. It's completely fine, but people don't usually go about it. Like there are things which you can tweak around and stuff, but you never want a data loss to happen. So that's kind of a bit dicey. But again, for caches, it still works because obviously why not? Then there is write around, as the word itself says, around. Go around and write it to the DB first. So I will write it to the backing DB. Now what will happen is that whenever someone asks from the cache, let's say for a key one, cache had a value A, but then I said write around that key one, write the value B. Now I will simply go and write around which means go around and write it. So I'll go around and write it to my DB. If I will do that, whenever someone asks from cache, bro, what is the value for key one? He will literally immediately return, bro, it is A. He did not go back and check DB. No. The moment after 5 minutes, or let's say after X minutes, it will expire, which means it will go away because obviously cache is limited. So we have expiration or eviction policies in hand. Now again, I will not explain eviction policies. For that, you have to go and watch the DSA video which we have. And again, watch this video only. I don't believe other DSA videos. But yeah, coming on back, when it will expire, then the cache will not have the data. So next time when I ask for key 1, then he will say, bro, I don't have data. No worries. I will check back with my DB. So it will go back and check the DB for any read request which is not with him, and then he will get it and then he will return it. So you see that you will get the updated data obviously in future. With that, you are actually getting eventual consistency, because you will get incorrect or stale data until the cache data expires. And then when it expires, then you will actually start getting a fresh data, which obviously indicates eventual consistency. Eventual consistency actually means, for the folks who haven't gone into bit of HLD, it's more of that my system, here cache is my system. Cache is eventually consistent with my database. Consistent, which means as is. And again, consistency primarily can be deferred by just simple one entry as well. So if it is not consistent for even one entry, I will say they are not consistent. If they're consistent for all the entries, then I will say they are completely consistent. And eventually says this will eventually become equal to my DB. Eventually, whenever I will have some expiration policies, I will have some, obviously with that I was saying that we will have some time-based expiration as well, so that things can become consistent, obviously. Now we saw write back, we saw write around. There's one more, which is write through. Write through says the entry will come up to the cache, right? Again, this is a write entry. It will come to the cache, and then it will have to go to the DB. It will be ingested here. Then acknowledgement will come. Then I will send the acknowledgement to the user that yes, bro, you got your write written. So you saw that write speed will be slow, but it will be giving you data consistency, and that will be very important. But yeah, any reads can simply go and check the cache. Now you might argue, Arun, like what's the reason? Like I'm still writing your DB. Yes, you're writing your DB and waiting for it to complete because you don't want to acknowledge by just saying, bro. Again, like you don't want that. Okay, I'll just do a write, and then the moment it reaches cache, I'll just acknowledge, yes, bro, your write is done. No, you cannot, because what if the connection breaks down here, right? What if let's say while it is coming back, the connection breaks down here? So you want the person to be acknowledged only when, because again, they have chosen write through for a reason, right? They wanted the DB to be written and they wanted it to be known or acknowledged that yes, it is written properly. So that's the reason. What we will do, we'll just simply write it to the cache, send it to the DB. Again, although this happens synchronously, right, like this, but in the code, right, in the code, when we are doing a write, I have just run 2 threads to just write it, and then when both completes, then I'm returning it. It's completely fine. But yeah, like it actually happens synchronously. Now, coming on back, multiple reads can actually happen parallelly, because obviously the read throughput of cache is very, very, very high. And again, obviously in comparison to DB. So I can simply read, and again, because it's completely consistent, so I will be getting obviously the correct data. Now, out of all these, what we're gonna go about? We're gonna go about with the write through, because it is much, it is much, in terms of like look wise, it's much more consistent with the data that I want primarily. Again, I will not go because it can have the data loss. I'll not go because these are eventually consistent. Although in real world scenarios for cache, it's completely fine. If I have some view count, if I have some, like count, it's completely fine. Like if I just miss, let's say 5 or 8 likes from some video, or let's say if I miss 5, 10 views or even 100 views, it doesn't matter as such, because obviously eventually things will be consistent. But maybe if something is more critical and you still want to cache, let's say if there are some tokens for something, then you wanted it to be happen again. And I'm giving a very random example, although we'll see in very depth in HLD course properly about the examples and stuff, but this is the idea. So we will use write through policy that I want my DB to be consistent. Now, if that's the case, then let's see what issue can come up if we do concurrent reads and writes. So let's take that concurrent reads and writes. So obviously this is you as in like you who will be putting up data. Again, I have removed the service layer for now for easiness. Then we will have a cache and then we'll have a backing DB. Now for this backing DB, let's imagine that I ran a write command for a key one with a value of A. So a write command went, obviously it will have to go through the DB, and then this acknowledgement came up that yes bro, it is done, and obviously this acknowledgement will come to you. But before this acknowledgement could come up, right, at this step you ran another write command for key 1, put the entry as B. So again this will go to the cache, this will again tell DB bro please update it, then DB will again come back by saying yes bro, I have done, and then obviously it will return back to you. But before that, imagine that you have asked for a read command. Now read command will again go to the cache. Now because it knows that cache has the data, so it will simply come back with the corresponding read value. Now because by that time write request of 1, right, key 1 write a value of A, that would have come up by that time, which means that I have only got the acknowledgement of the first command which I ran. But because write did not have to go through so much and it's pretty fast, I just simply got write reply. But at this point in time when I got the write reply, my cache only had key 1, so I would return key 1. But for a user perspective, just imagine that you updated the entry to A, then you did a B, and then you did a read. Is it okay for you to still see a A? No, you will be literally so badly mad that I did the update. Is my system hanging? Is my system, like what's happening with it? You'll be so confused. So ideally you should have got a B. That was what you should have got ideally, but what you got A, just because of how system works as an acknowledgement works. Because obviously if some write happened, it came up, let's say it came up here, and then you got the acknowledgement, okay, the key 1 of A has happened, but then read actually happened very fast, and then the other write, the previous write, it happened and came up later on. So again, my first question is that how will you resolve such a issue? That the issue here is that if someone has written something, he should read that latest value what he has written. That is my primary task. How can you resolve this? What is, again, obviously there will be multiple people writing, but even if we ignore multiple people, imagine he's the only one. Like I am the only one, he will be writing only one key 1, and then I will be reading that. How will you acknowledge that? Or how will you go about that? Obviously, I should go ahead with making sure that I am reading my own writes. Because again, now you might say Aryan, but what if some other person came up and then they just did some write of key 2 with a A? Okay, for this person, as he has not returned that K2, so he's not concerned about it. It's completely fine whatever happens with the K2 or other key. I'm only concerned about what happens with my own writes. So what I will do is I will try to have it on a same thread, which means I will try to achieve read my own writes by keeping my own reads and writes or all the operations sequential. Again, that's a very, very, very important word. I will keep my own reads and writes sequential. Although on theory, if there is someone else who is writing key 1 with a value of, let's say, 5. Again, this is, let's say, someone else. Let's say here John comes up, here let's say Max comes up. Now ideally the all this operation for same key but by, let's say, John can happen independently of Max, but which means I can actually make threads on user basis, but we will make on key basis. What I mean by that is that we remembered that we want to operate these tasks consecutively. That first, because obviously this task came first, then this task, then this task, so this should happen one after the another. So what I will do, I will send, so like the first task comes up, I will send it to a thread that, bro, this is the first task. Key 1, like write operation, key 1 with a value of A. Then this operation comes up, I will send it to a thread that, bro, this is another write operation, key 1 to a B. And then this is key 1. Again, I'll send it to the same thread, that write operation, sorry, read operation with the value of key 1. Now, the beauty of thread is there cannot be any parallelization inside a thread. It's not possible, and we have already seen that when we were seeing our multi-threading course, crash course, that there cannot be parallelization inside a thread. And with sending for the same key onto a same thread, I can always make sure that I'm following the ordering. So I will follow the ordering, which means that only when this succeeds and this will go away, then I will operate this. Only when this succeeds, this goes away, then I will operate this, and so on and so forth. So what will happen ideally in this case is that you will wait for the first write to complete, then second write, and then you will tell the person to allow reading. Aryan, won't it be slow? Yes. And that is the reason we want it to be consistent. Again, if you don't want this consistency, which is very normal for caches, you can remove this logic as well. But obviously, we just want it. That's the reason we have taken it. But again, it's a cache. It is built to be eventually consistent. So it's completely fine if if let's say a business supports reading stale values or reading a bit not fresh values, it's completely fine in caches. It's completely fine. Again, I'm saying it's completely fine. Now, the reason I mentioned for the same key, although you can handle it on the user basis as well, you can cache by a user, and then again, when I say hash by a user, I mean that how will you make sure that for the same key it will go to the same thread? Obviously, because there are multiple threads, it's a cache. Multiple threads can actually access it. Again, now these multiple will be also limited because we cannot make infinite threads. That's not possible. Obviously, it takes resources, and I cannot give infinite resources. So, but yeah, I can have infinite keys. I can have literally 1e9 keys or 1e18 keys, which is very lot. I will have, let's say, 10 threads only, which is limited. So obviously I want that all these keys should go to one thread and one thread only. So what I will do, if let's say it's a key 1, he should go, let's say, only to thread 2. That's it. So I will simply do a simple hash, which means for this key 1, I'll do a hash. Whatever the hash says out of these 5, wherever you have to go, you will simply keep on going there only. All operations for this key will go onto this thread only. With that, obviously, my ordering will be imposed, and obviously, with that, my read my own rights will be imposed. Now, if you want, you could have also gone into user-based hashing, that for a specific user, maintain a user who is doing this entry, and then based on that, hash it. And then you can also, do all these tasks, but then you have to make sure that you are hashing user and a key. Make a string and then hash it. So that's also what you have to kind of go extra mile to achieve that task. The concrete for a specific user reading his own rights only and not concerned about any other rights. But again, to keep it simple, we just have hashed with a key. We don't care about who the user is, if it's Max or John. For everyone, if it's the same key, it will go to the same thread. But yeah, obviously, if you want to, more make it more, more better, or maybe more kind of specific, you can actually do that. Make a key of user and a key, and then with this key hash it, and then hash it and put it to a thread. With that, you can do more parallelization, and also keeping your constraints in mind. Now, with all that said, now you literally have a very good system. Obviously, the speed will be a bit slow if there are many writes or many obviously if there are many writes from one person. But yeah, it will only be if I have writes and then some scheduled reads. Right? Because again, if there's only a read of a key 2, I can simply go and check back. I don't have to wait for anything. But if there are writes, obviously I have to wait for acknowledgement to come up. And then I should make sure that, okay, now it is done. Now, let's actually start off with what I was mentioning. Because now you know everything. So now we can start off. So, as soon as you got to know about, your task, you were doing the very basic stuff. Managing limited memory, key values, and writing, and using the Java generics for the key value and making the thread safe. But then you realize that you obviously would have to have eviction policies because it's memory, and memory doesn't have that much liberty to extend. You will have write policies as well. Now we discussed, write around, write back, write through. We will be using a write through. Now I will have to ensure read my own writes consistency. Now, obviously, as I mentioned, it's not important, and if you want, you can ignore this as well. You can only focus on let's say write policies and eviction policies. But again, it's totally up to you and your interviewer. But yeah, this is kind of extra mile, extra level. If you know about it, then it shows that you actually know about HLD and stuff. Now, because of that, we are saying that because it's read your own rights, all operations from the same key should be handled by the same thread, and that's what we actually said. And this will help us maintain ordering along with maintaining read my own rights. Now, with all that said, I know that for all the reads and writes for the same key, we'll simply go to the same thread. And because we know that a thread cannot parallelize a task, which means that all the tasks which go to the same thread will have to run sequentially. And when they run sequentially, they will obviously maintain the ordering in which they will came up, in which they comes up. With all that said, I can simply ask some clarifying questions that if they want some specific write policies to be implemented, because I think so write through, but maybe they want write back or write around, can be possible. Now, any specific eviction policies, 99% time they will say LRU, even 100% they will say LRU, but still you can just ask that I'm thinking of LRU. Do you want LFU or maybe hybrid LFU plus LRU? Again, it is very complicated. Don't write it down. It's impossible to write it down. But yeah, LFU is still easy. It's kind of easier than LRU, but still LRU is very, very good. So we use LRU in most of the senses. With all that said, we are done. We'll just simply, get some reply from our interviewer, and he will say, yeah, we should support ideally different write policies, which means that ideally I should inject any write policies whenever I want, which means that I will use my strategy design pattern here. Right? Again, okay, one design pattern will be obviously used, which will be strategy. But yeah, I will only implement one, which is write through. Then I should obviously also support different eviction policies, but I will implement LRU. Again, here as well, we have to inject different eviction algorithms. So which means again, it will support strategy design pattern. Now, the prime task was, he also wanted us to cover is handling concurrent operations, but making sure that these does not corrupt the state. Now, considering it's a hash map, concurrent operations are happening. Obviously, again, I'm not sure, but obviously, when I say I'm not sure, which means at this point in time, although I know I have made the videos, so I know that we will be using concurrent hash map, but at this point of time, you can simply say that obviously because it's concurrent operation, we have a key value pair, we can use our concurrent hash map. Now, for the folks who don't know what I'm talking about, which means you haven't watched crash course, multi-threading crash course, it's roughly around 7.5 hours crash course. Please watch it. It's very important, very, very, very important. If you're looking for any firms which are a bit more, which have a bit like which pay a bit more, they will ask a bit more as well. That's as simple as that. Now, coming on, we have to ensure read our own rights, and simply we will try to have a key-based hashing, and I will route all the keys to the same thread. With that, I will get ordering. Also, I'll get read my own rights. Now, ultimately, I will be using Java generics. I will do my read my own rights, and I will have different eviction algorithms and write policies. With all that, we can simply tell that considering it is already a lot of stuff, because again, implementing LRU itself for many folks can be a tricky job. On top of it, just implementing multi-threading and read your own rights and write through and all that stuff will again be a challenging task. But I hope so that you are very, very, very familiar, because again, we have also marked this question as very important, and because again, it's literally asked by many companies, so that this is a very important question. So I guess you will implement this in just 15 minutes. Rest of time you will keep it for multi-threading. But we will ignore a lot of stuff, which means request collapsing. Now, what does this mean? Although I'll just not go into deep because it is out of this syllabus. But the cache, if it gets a lot of cold, let's say reads, but the cache does not have the data, so it will let it pass to the DB to actually get it. But if there are a lot of requests, and let's say if it's for the same key, but it came simultaneously, but the cache did not have the data. So cache, because cache asks DB for any data if it doesn't have it. So all these requests can actually go to the DB as well, which means loading up a DB to an extent which it cannot handle and crashing it. That's the reason we do one thing, that for the same key, we just collapse the request and only send one request for that key. Again, you can use multi-threading here as well, but obviously we will ignore it. Hot loading, simply because obviously because of this scenario in the boot up, I can simply load some entries from the DB, which obviously I know can be pretty beneficial, and that's what I can do. Again, event logging, head of line blocking, the same thing which we discussed. Now what happens is, next we'll go on to key components. Although whatever I told, you might say, Arun, it's 40 minutes, you have already explained it. So this I have told you, your only task is just to showcase what you know and cover the, or ask the core requirements, and then the person will tell something, okay, this is what we want to cover, and then jotting it down and then proceeding ahead, right? Don't end up explaining, read your own rights if the person is not asking for it. Cool. Now let's see, we will have core components. Again, this exact same flow which we have been using all time now, that we will have some core components, then we will go on and see the corresponding design challenges, which will involve, let's say, multi-threading and so on and so forth. And then we will try that what are design principles we can actually use. And then we'll go on to the actual implementation by just having a glimpse on the class diagram. Do I make the class diagram? Never. If you want to know why never and so on and so forth, just please go and watch the previous LLD videos. From the beginning, you will get the idea. Now, coming on back, we know that because I have to store, it's a cache, right? So I need a storage, concrete storage for a cache. So I'll use a cache storage. Now, because I know I will incorporate generic, so I'll just use key and value. So this K and V are generic. I can literally put up anything. So obviously, because I can incorporate different kinds of cache, so I'll make the interface for it. So I'll say a cache storage. Same way, because I know in this problem we are having write policies in place, which means I have to showcase the interaction between cache and DB. So I have to keep a DB storage as well. Again, although I'm keeping it also as a key value pair, but this also will be interface so that it can be plugged with something else as well. Now, obviously, we will see later on in future the concrete classes, but if I just wanted to show you the structure, you will realize that we have this storage mechanism in which we have these storages, cache storage and DB storage, and I will have concrete cache storage, which is, let's say, in-memory cache storage, and concrete DB storage, simple DB storage. Although both are in memory, because obviously I cannot actually build a DB connection here. It's not possible. So yeah, and like when I say not possible in this time frame. Next is, obviously we are discussing about write through and eviction policies. So again, I will take that I know I have to use strategy pattern here. So I will use the interfaces for them as well. So I will have a write policies. Again, generics, eviction policies. Again, eviction will simply say key accessed or evict key. Now, why and how would I know, Aryan, that what actual methods should be inside the eviction algorithm? So see, eviction will say evict something. So obviously evict something. But when does evict something? Evict something when it has become old. It will get old when it was not accessed. So whenever something is accessed, you will call this method which will put that entry onto a new position which is in front. So anything which remains in the back can be evicted, and that's where I can just keep it. Again, it's not a hard and fast tool to keep these methods. You can actually replace these methods with something else as well, whatever you feel comfortable. But yeah, this is how you can relate that. Okay, Arun, how would I know which method to actually put up? Now next, because we were actually having those storage interfaces, then I will have concrete ones, which I mentioned also, that in-memory cache storage and simple DB storage. And I will also have concrete implementations of write policies. So I'll have write through policy and I will have LRE eviction policy. So again, if I just show you, storage mechanism is done, then I know that I will have write policy. So I will have a write policy interface and a concrete write through policy. Same way, I will use eviction algorithm and then concrete eviction algorithm, which is a concrete eviction policy. Same, why we took interfaces, because we want them to inject, and so that I can literally make lot more eviction algorithms. Coming on back,
apart from it, because you know that we are now about to go and implement LRU, and for the folks who have watched the LRU video, we know that we want a doubly linked list node and we also want a doubly linked list. So obviously we will be needing these two at least. So I'll just make the same thing. I'll make a doubly linked list and I'll make a doubly linked list node. Doubly linked list will have doubly linked list nodes, right? So I'll do that. Now, on top of it, what else do we need? We have to do multi-threading, right? If you remember, we have to do multi-threading. So that was actually done. We were saying that for a specific key, I will try to route it to a same thread. So I will need to have a class which can actually handle this job, you know, hashing a key and then putting up to the corresponding, task and stuff. So I will have a key-based executor. Now, again, you can name anything, whatever you want, key-based manager, executor, handler, so on and so forth. The only task here is that it handles that key hashing and then routing that request to a specific executor or a thread. So we'll also have a key-based executor, which will simply handle that for a specific thread, I will hash it, and then it should go to a specific location only. So for a specific task, it should go to a specific thread only. Now, obviously, when everything is done, it seems like everything is done. We have covered write policies, we have covered eviction algorithm, right? We have covered the storages, cache storage, and DB storage. Literally seems like all things are done. Then we have covered the underlying eviction algorithm, need LRU. So I need a DLL node, I need a DLL itself. Then because there's entirely, this routing involved, so I can have a key-based executor. Seems like everything is done. But obviously there should be one orchestrator who will just perform all the tasks, right? So I'll just name it as a cache. You can name it as a cache manager or do anything. But yeah, that's kind of a main orchestrator which we have. So that is my cache, which will have the primary entry point. So anyone who wants to put, insert, or call it, they will call this controller, cache controller, you can say. Now, let's come up and let's see what are the design challenges, and then we will go on to the design patterns, and then we will go on to the design, the actual class diagrams, and then we will start implementation. So it is same thing that we want to have thread affinity, we want to implement eviction policies, we will have write through policy. Again, here we will have LRU. Yeah, and we'll have cache consistency, which means read your own writes. We'll have key-based hashing, for which we have, key-based executor, which we have. Now, obviously, we will try to use strategy pattern for our eviction policies and for write policies. Then we have thread affinity, for which we have made a new class altogether, key-based executor. Then we will use completable features because I want to asynchronous, I want my operations, asynchronous operation to be returned back. Again, this is more of if it is required in the code, then you can come back. You would never know in the beginning if you would be needing it. Obviously, if you have watched the video, our video, then probably you would know it. But yeah, it's kind of hard to just say in the beginning itself, I will use this, I'll use that. But yeah, the only catch why we are trying to use here is because, as I mentioned, we want to keep it a bit diverse. This we kept it very simple. In this we are trying to incorporate more, because we have already learned about completable feature. So I'm just trying to make you more familiar with concepts which you would never see, and thus you will think that they are never asked. It is not like that. You should be knowing generics. Ideally, you should be knowing about completable feature as well. Obviously, if you're SDE2, you should know it no matter what. If you're SDE1, probably it is okay that if you don't know about such concepts and stuff. But obviously, if you want to do a switch, you will have to know about it. Now, coming on, I will be trying to use concurrent data structures, as I mentioned in the beginning as well. Primarily will be concurrent hash map, and that is one thing also which I mentioned while we were discussing collections, Java collections, that concurrent hash map is very, very, very important. Now, I'll make sure that I'll use strategy patterns so that I can incorporate any new policies, even write policies or eviction policies in future. Now, with all that said, we know that it is a very simple components. As I have been mentioning every time I tell you this class diagram, you cannot make it, but it helps you to showcase that you only have a couple of stuff. You will have a cache storage, right? One is interface and one is concrete storage. Then you have a DB storage, one is interface, one is concrete storage. Then you have eviction algorithm, one is interface, one is concrete storage. Then you have your, for LRU, you would need your DLL and DLL node. For your write policies, you will have an interface and you will have a concrete class. Did you see that this is all and everything we actually also saw? So it's pretty easy to actually even put it down. Will you make this? Not really. Will you make this relation stuff? Not really. Right? Okay. Now, there's one thing extra which we saw was the key-based executor to actually handle that key-based affinity and routing. Then our main god class is cache, or you can say a cache controller, which will accept all the entries or all the requests from the user. Now, with all that said, let's actually start off with the implementation. I know it's a bit off. We have discussed a lot of stuff, but I think it's important considering you are, one step ahead, kind of. Now, obviously we know that we'll have to have a storage and a cache and a storage. So I'll use a cache and a database, again the exact same which we also saw, that we are having cache, a cache and the corresponding storage for it. Now you might say, Aaron, like here the folder pattern is like this, interface and then concrete classes. Here the folder pattern is interface, the concrete classes separately. See, that doesn't matter. If someone is nitpicking on your folder design, and if it's kind of not that much relevant, it's kind of more of a nitpick. People do it in industry, I know it, but yeah, it's totally up to you. If it make logical sense, it's completely fine. Coming on back, we will have a simple cache storage interface which will have a lot of stuff. I will put something, I'll get something. Again, you will see everything is generics. So generic simply says that you don't pass in the actual key value pair, rather you say key and w, like k and v. These are generics which can be replaced with anything. It can be string, it can be int, anything it can be replaced with, and I can simply place it here. So you will see anytime my any type will be a k or a v and not actual concrete types. With that, I will be incorporating, or I'm incorporating generics in picture. Now, obviously, the methods will be get, put, remove. I can check if the key is there or not, because obviously, I can do that check. Size and the capacity of my cache. DB will be very simple. Just write, read, and delete. Right now, concrete in memory cache will just be implementing these put, get, remove, and your contains and your size. Now, what it will do? Simple. It will use a concurrent hash map. So I'll just make a cache as a map. I'll say it's a concurrent hash map. Again, the key value will be same, right? I want the key to be generic, value to be generic as well. If you want, you can make classes as well, and then in the classes you can keep them as generic. It's totally up to you, however you want to go about it. Even if you don't want to go about it completely hardcore, it's completely fine. No one will argue about that. Obviously, as a follow-up, they can ask you, how will you make it generic? But not really if they want to just, very much deep dive into it. Now, again, all these are very normal methods, just putting up and just getting it and just, removing it and so on and so forth. Just a very normal operation, which we can do on a simple concurrent hash map. Now, same way for simple DB storage. Again, this also I kept as a concurrent hash map. Very same. Write, read, and delete is a very simple operation on a concurrent hash map. This does not indicate the cache operation. The cache, actually, again, the underlying cache logic, we will keep it separate via using an LRU and stuff. But this is just to showcase, okay, the backing cache storage is this thing. The algorithm is something different. We will see. But yeah, this is just a backing cache storage, just a hard storage. Now, before we go on, we'll know that we will have different write policies. So I know that I will have a write policy in which I will simply have a simple method, right? Again, it's an interface so that I can use strategy pattern here. So I'll simply say that write policy says interaction of a cache with a DB for a specific key value pair. So for a key value pair, how my cache interacts with my DB, that's my write policy. So my concrete write policy, which is a write through policy, simply says that, bro, you do one thing, that I have to simply do a write. Although I mentioned that you can perform this task synchronously. That firstly write onto cache and then write onto DB. When this is done, obviously they were done synchronously. Then you can simply return that yes, it was done. But here you will see that I just make two corresponding threads. When both of them are done, then I will simply say it is done. Now, if you are just worried, Aaron, what is this computer future? What is this all of? Which means you haven't watched crash course. Multi-threading crash course, which we have done. You haven't watched it. That's the reason you are confused in that. Now, next, we will have the similar for eviction algorithm, right? Same interface that the key was accessed and the evicting a corresponding key, just giving that if I evict a corresponding key, this is the key which I evict, and this is the key which was accessed. Now, before I actually go on to eviction algorithm, I know that I will be implementing a LRU. For implementing a LRU, I know that I will be needing a DLL node and a DLL, right? Doubly linked list and doubly linked list node. I will not go through the logic of DLL here, but a simple logic of DLL looks like that you will have a doubly linked list as soon as a node comes up. Let's say if a new node comes up, I will attach it to the end of my doubly linked list. If an existing node is accessed, I will simply remove it from my DLL. So I should ideally remember that for a specific node key value, what is the node reference I have, I will remove it, and then I will firstly plug these connections, and then I will put that accessed key into the end. That's a simple logic of your LRU, or your simple access, which whatever it is done. Now if you don't know about it, simply go and watch that cache video which we have, LRU cache video. Now coming on back, we'll use a DLL node. The only catch here is now it is generic, so I will have a value and I will be addressing my previous and the next node as the same thing. Now I will obviously be using my DLL node inside my linked list, DLL W linked list. I'll say I'll have a head, I'll have a tail, and then if I want to add a specific node, I'll simply add it to a tail. If I want to detach a node, I will simply remove it and build the connections from previous to next. And then if I want to get the head, again, this is not that head because I know it is impossible for you to get that head, but this head, it's easy to get. It's at the very back, so I can easily get that head. And if I want to remove it, I'll simply remove it, and also I'll just simply say the new head will become this. As simple as that. Again, all these operations, if you want to go in this logic detail, which is this logic detail, please go and watch the DSA video. Now with all that DLL and DLL node in our mind, now we can start building our LRU algorithm. So this will simply, again, this is also exactly same, because I need that for a key, what is the node reference, because I want to access that node and remove it when needed so that I can access its left and right. So from a key to a node, I will keep it. From a key to a node, I will keep it as a hash map. And then I will also be keeping the actual doubly linked list where the actual entries will come up. And obviously this will have a capacity as well. So whenever a key is accessed, I should make sure that if it is already there, then detach it wherever it was and then add it to the end. Now if it is very new, then simply add it to the end. That's it. Now if I have to evict some key, I will simply make sure that I am evicting the corresponding key. Again, obviously if the capacity goes full, I'll simply evict the corresponding key. That's kind of where my eviction lies in. Now comes back that we'll have a key-based executor, which is kind of the prime core if we're gonna go about in the multi-threading sense. So my key-based executor will say that, bro, now I could have made different threads manually, but I thought, okay, why not? We will use executors because these help us manage threads very efficiently. Because again, for the folks who don't know what executors are, please go and watch crash course because we have discussed executors in pretty detail. Now, coming on back, we realize that, okay, we can use single executors. Now, why single executors? Because we want that for a specific key, when I will hash it, it will be lying on, let's say if I would have had, let's say 5 threads. Now I am saying that I will have 5 executors with each executor having 1 thread. So it is kind of making my task easier to handhold stuff. So I'll just hash it so that it points to one of the executor. That's it. Which internally mean that it will be handling 1 thread because it's a single thread executor. Now with all that said, whenever a task comes up, I will submit a task. Submitting a task means that for a key, just submit a task. Again, if you're worried about supplier, all that stuff, please, this is a very normal Java concept, predicate, supplier, and so on and so forth. Please make sure that you know about them. Now, again, even if you don't know about it, even if you hard code some stuff, it's completely fine because obviously it's a lot of stuff which I'm going to tell in this video, which primarily means that I want to cover Horizon with different videos because obviously, depending upon at what level you are, things will change. If you are more senior, you will be expecting more multi-threading, more generics, and more robust system. If you're a junior, obviously it will be much more relaxed, much more concise. So we tried to cover in different videos different things. So watching the entire course is very important. Now coming on back, we realize that, okay, we'll just simply, for a key, we'll firstly find out the index is nothing but that which thread I should go to. So with that, I will just call this, which will simply do a hash of my key, again a very simple hash of my key, and then I will get the corresponding index. With that, I will simply say that this is the executor I will go on to, and with all that, I'll simply say that, this task on this executor should be run. When it is run, again, if you don't know what this is, make sure that you watch the crash course video. When this is run, I'll get a completable feature, and then I can do whatever I want with this. Now again, shutdown is very important because you wanted your resources to be shut down. Ultimately, finally, it's very important, else you will get leaks and the system will go very bad. Lastly is our main class, the cache class, the god class, which we have, which will perform the actual task. Because again, all the other classes were actually handling their own operations, but to coordinate between them, I need to have a cache class. So what does this say? This simply mentions that I will have all the classes: cache storage, DB storage, write policies, eviction policies, and my key-based executor. In my constructor, all of them came up. Then whenever a data is accessed, so obviously I will have to go and route this key to a specific thread. So I'll simply go and ask my key-based executor that, bro, submit a task in which a key is being accessed. As simple as that. And again, I'll just give the corresponding task that if my cache is not having that key, then okay, simply return. Again, I could have gone onto my DB and then put it back, but keeping it simple, I'm just keeping it simple right now. And if it is having the corresponding key, then make sure that it is accessed. So your eviction says it is accessed, and then you can return that key. Now, if you want to write or update some data with some key and with some value, obviously you will simply ask your executor again. Because again, why you're asking him again? Because he will route that task with that key onto a same thread or onto a same executor. Now you will give him a task that both the task is that if the cache contains the key, and now you're updating it, which means that firstly make sure that you are writing that, and as you are writing it, which means that also make sure that you are kind of saying that that key was accessed because you're updating it. So if that key was there, you just touched it and then updated it, so it will come in the front. As simple as that. And same way, if the cache becomes full, then obviously you will have to run eviction, which means that you will simply check first that the thing which is being evicted and the thing which I'm trying to insert. Now, if whatever I'm trying to insert or update, and whenever I say update, I mean actually putting up as well any new entry as well. It's same. Now, whatever was trying to evict, because obviously the cache is full. So whatever is trying to evict and whatever I'm trying to update or add, if both of them route to the same thread or same executor, then from the cache I'll simply remove it. Remove that entry manually or sequentially. Sequentially I'll remove it, and then I know that sequentially I will add it to my cache, and also I will access that from my eviction. But if it's a different thread altogether, then I can run that on that separate thread. So if it is not sequential, if it's not hashing the same key, no worries, I will run it parallel. It's kind of keeping it a bit more faster, but yeah, that's completely fine. If you just even keep this also as sequential, it's completely fine. Now, lastly, my client code looks very, 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 very simple. That I will have my corresponding classes. Then I will try to add data. So firstly, I will have a A, then I add a B, which comes in the tail, then C, which comes in the tail, then D in the tail, then E in the tail. Then I try to add a F. So F comes up, but obviously we know that F comes up, capacity is breached. So A will go away because it was in the head. Then I try to access A. There will be no data because A is not even there in the cache. Now, again, you could have had a condition that, okay, I will just access A, I will bring it back from my DB. All that stuff is not required here because you want to show LLD concept, right? That's the main point here. Now, when you access F, you will get the F value, which was fig right now. Then when you access B, the B will be replaced and will come up in the front, and then you will get the value which is blueberry. And then obviously it will shut down. This will shut down the executor and stuff, and you are done. All these values are literally here. So with all that, you were able to achieve separation of concerns because you literally have a lot of different classes for it. Single responsibility was maintained more or less, yes. And obviously you were having a good structure in which you have interfaces, concrete implementations, and it is much flexible. Obviously, you might argue then, Aryan, why did not we do such flexibility in all these problems, right? Again, as I have been mentioning, that every problem focuses on different stuff. We did not focus much on design patterns here because we did not use factory, we did not use any other design patterns. Why? Because we have covered already here. And here, and again, as I mentioned, that this is not a one-shot video, that if you just watch this video, you are done with LLD. No, you have to watch the complete course. Until then, you will not get everything. Now, lastly, just to wrap up, we are having separation of concerns, we are following single responsibility, we are handling asynchronous operations as well very well. We are using design patterns for our write and write policies and eviction policies. And also it is easy to extend for any new cache type, any new DB type, any new write policies, any new eviction policy. It is very easy to extend, and that is the beauty. Cool. I hope you guys liked it. Again, we tried to cover a lot of stuff because it's important, because many people just try to cover from a very high level and just expect that I know LRU and then I can write it. It doesn't happen in real world like that. Again, telling by experience, it doesn't happen like that. You have to know about stuff, and it's good that you know about them. Even if you don't remember them, no worries, come back later on in future, because obviously it's a lot. You are covering generics, you are covering multi-threading, you are covering design patterns, you are covering concurrency concepts as well. It's kind of hard to get all of them in one video, and that's the reason we have kept it in the very end, such that you are comfortable and then you are coming onto it. Cool. Bye bye. Take care. If you liked it, make sure that we hit the like target of 250 likes, and see you in the next video. Until then, goodbye. Take care. Bye bye.